Hi and welcome to part 6 of the circular functions revision. This question we're asked to state the amplitude and the period for the following. So, first one here, we have our amplitude. Is 2. Simple. Okay, for the period, that's equal to 2 pi over n. In our case, n is equal to a half. So it's equal to 2 pi divided by a half, which equals 4 pi. That's the first one done. For the second one here, our amplitude is equal to 3. Goes up 3 and goes down 3. Don't need to worry about the negative sign. The negative has got to do with reflections in the x-axis. And the period equals 2 pi over n, where n is equal to 4, which that will equal pi over 2. And that's the second one. And the third one, the amplitude equals a half, and the period equals 2 pi over n. N is equal to 3. So that's just simply 2 pi over 3. And that's all you need to do for that question. Let's move on to the next one. Everyone's favourite, sketching graphs. Now, first one, we have a cos graph. Now, to just remind you of the shape of a cos graph, it would normally go something like that, with the period of 2 pi and maximum of 1, minimum of -1. Okay, so we have an amplitude of 3, so it's going to go up to 3 and down to -3. This bit here tells us it's going to be reflected in the x-axis or flipped upside down. And this bit here is going to change our period. So the period will equal 2 pi divided by a third, which equals 6 pi. So one cycle is going to take all the way up to 6 pi. So to sketch the graph, we can start off with the basic cos shape, like so. We've worked out from the period that 6 pi is going to be the end, the halfway point will be 3 pi. From our, oh, I've actually mucked up there. Let me do that again. I forgot one little thing. Little saying that the difference between a master and a beginner is that the master has failed more times than the beginner has even tried. So, try it again. Now, I forgot this thing here. We flip it upside down. Lucky I realised it before I finished, eh? So, one period is 6 pi, halfway point is 3 pi. Label my x and y before I forget there. And the amplitude means that we go -3 down the bottom and 3 at the top. And that should do us for a sketch graph. Now for the second one, just to remind you what a sine graph looks like. With one period to 2 pi, it goes up to 1 and down to -1. Now we again are going to be flipping it upside down. We have an amplitude of 2. Our period will equal 2 pi over 3. So to sketch the graph for this one, again remember reflected in the x-axis. So we'll start there. There's no horizontal translations at all, so we'll do one cycle of the graph. Period is 2 pi over 3. The halfway point will be half of 2 pi over 3, which is just pi over 3. We'll continue. We've got x and we have our y-axis. Our maximum from our amplitude is 2, and we'll go down to -2. Okay, so that's the second one done. Coffee percolating away in the background there, so I'm going to disappear very shortly for one of those. Now the next one, again we have a reflection in the x-axis, so flipped upside down. The amplitude will remain as 1, but this tells us that it's going to be shifted to the left by 2 pi over 3. So again, well, we've got our little copy of the sine graph there. Instead of it finishing at 2 pi, we still have 1 here, so it's not going to be changing the length of the period. So it's going to have a period of 2 pi, but it's all going to be shifted that direction by 2 pi over 3, which will change things a little bit. So to sketch the graph, I'll go into the negative realm for this one. We only have to show one period. But to get an idea of what the shape of the graph is going to look like, I'll start with just a little demo copy here that we can use to explain it. At the end here, we've had our 2 pi has been shifted to the left by 2 pi and 3, so we're going to have to work out 2 pi, take 2 pi on 3, which will be 6 pi on 3, take 2 pi on 3, which equals 4 pi on 3. So that tells us the end here is going to be 4 pi on 3. Now, half a cycle is pi, so here is going to be at pi on 3, and then we go back another pi, and this will be -2 pi on 3. That'll give us an idea of the shape of our graph. So we're going to have our y-axis come through there, and this is where the x-axis comes through. So to draw that graph, it's going to be something like so. We're just talking one cycle here, so this is 4 pi over 3. Our halfway point was at pi over 3, and here we have -2 pi on 3. Let me see if I can shrink all this a little bit, just so I can show you how we work out where the y-intercept is going to be. So for the y-intercept, we make x equal to 0. So in this case, y will be equal to negative sine 0 plus 2 pi and 3 is just 2 pi over 3, which is, if I draw a little unit circle, -2 pi on 3, we go around to -pi on 3, -2 pi on 3, so it's going to be the equivalent in the third quadrant. So sine is negative down here, and it's going to be the first quadrant equivalent of pi on 3, because it's pi on 3 difference to the nearest horizontal axis. So pi on 3, which is equal to a third of 180, which is 60 degrees. We use our little 60-30 triangle. 30, right angle 1 to root 3, and sine of 60 degrees is, sine is opposite over hypotenuse, so 60 opposite root 3 over 2. And because sine is negative down there, this is going to be our answer. So negative root 3 over 2 is going to be our y-intercept there. So the y-intercept occurs at 0 and negative root 3 over 2. Hope that makes a bit of sense for you, and that'll be all for this one. See you next time. Well, you won't see you, but you can hear me next time. Bye.